So we also have, as I mentioned, we have distance vector, link state, and hybrid. Let's just look at let's do a very say shallow dive into a few of these ones. Let's start with the distance vector. So with distance vector, so basically routing is more about algorithms. How is it done? What happens? How does he understand what to do and all that? So basically, with distance vector routing protocol, we're looking at the Bellman-Ford algorithm. With Bellman-Ford algorithm, we're talking about the idea for routing is based on the number of jumps, then hops. It uses hops to decide how to get there. And with distance vector protocol, periodically, so after a few seconds, it'll come back and say, hey, I know about these networks. So if you need it, you can put them in your router. After a few seconds, it will keep reminding you. So basically, periodically, it will tell you that, hey, I know about these networks. And if you want to get it, this is how you get it. And when it's telling you about them, it will tell you, it will give you a full routing table. So it tells you everything. It's not just telling you about the new ones it knows about. It tells you about every single network. And this is what it does when it comes to say distance vector. Distance vector protocols normally will be classful. So for those who have done a little bit of routing, you realize that with distance vector protocol, it goes with the default subnet mask. So we're going to look at a very simple example, RIP, where we'll use the default subnet mask. Now, it means that if you do subnetting, you cannot use distance vector protocol. I stand to be corrected because version 2 is classless. RIP version 2 is classless. So we'll later on see that it's not the case. But it also sends this message as a broadcast, like the updates. So every device connected to it, every interface will be receiving it if it's a multi-broadcast network. And that's also not a good idea. Later on, we'll see what that means as well. So when you're choosing a protocol, you also need to be careful and know what that protocol does, because you may end up creating more problems than good. Examples of the distance vector protocols is RIP version 1, RIP version 2, and IGRP, which is no more being used, Interior Gateway Routing Protocol. And it has less overhead. So basically, it is easy to configure. And then it is the kind of configuration that you do on distance vector protocol. It's not too difficult to do. So today you see how we do it. It's so simple. The next routing protocol is the category of protocols what we refer to as the link state. And with link state, we're looking at what we call the Dijkstra algorithm. So with Dijkstra algorithm, we're looking at with the Dijkstra algorithm, you're looking at shortest path. So the idea is that in order for you to get to a place, they don't just look at the number of jumps. They look at the bandwidth, how fast it will take you to get to that particular destination. And if let's say you want to go here, and this place is like 100 megabits per second, and this place is like 50 megabits per second. Between the two, this link will be the fastest. So this guy would advertise only this link to this guy, say, hey, if you want to get to this guy, I think this is the best route to get to that guy. And so with the link state routing protocols, you'll be looking like the Dijkstra algorithm, which is more like using the best path. Again, even though it also sends updates about the networks that it knows about, the routers will be exchanging information. It's only at the beginning where the router will send all the information it knows about, but going forward, it will only be updating it based on what has changed. So if a network goes down, it will tell you what has changed. But with the distance vector protocol, it's like me saying, hey, my name is George. And every single time, if let's say I win an award, I'll still come back and say, hey, my name is George and I've won an award. If I'm traveling, I'll say, hey, my name is George and I won an award and I'm traveling. That's how distance vector protocols behave. But with link states, once I tell you, hey, my name is George, the next time I don't have to tell you my name is George. I'll only come back and say, hey, do you know I've won an award? The next time I come back to you, do you know I'm traveling? So the difference between distance vector and link states is that with distance vector, periodically it will come back and tell you every single thing it's already told you about all the networks. So there's a kind of an increase in the bandwidth utilization. But when you get to linked states protocols, we're talking about cases where it only talks to you about only the changes that has occurred within your network. And also with linked states protocols, it only does the update through multicast. So basically, it's only the routers that are communicating in that particular protocol. So OSPF, when you configure OSPF, you join a particular multicast network. And so all the updates is like when you join a WhatsApp group, only the people in that WhatsApp group will receive that WhatsApp message for that group. But with distance vector protocol, it's like saying that you send a message to everybody in your contact. That's different. So it's so much effort. But with link state, it's more like saying you've created a WhatsApp group and you only send it to people within that WhatsApp group. But with link state, with distance vector, you're looking at sending it to every contact on your phone. So that's the difference between link state and distance vector. Another thing is that with link state, it's a bit difficult to configure, especially OSPF. Oh no, sorry, ISIS is also difficult. But these protocols are difficult to configure because they come with the concept of areas and all that. So but the advantage between the advantage for this link state protocol is the fact that when a problem happens, you can isolate the problem and fix the problem within a particular area so that it doesn't affect other areas. But with distance vector, when a problem happens, it affects everybody, and even those who are not supposed to be aware will still get that information. And that's where the challenge is. And yes, a hybrid, which is the last one, is just a mixture of the two. So when we get there, you get to understand what these are.